break. Now we are going to discuss the third type of the loop, that is a for loop. We talk about while, then we talk about do while. In the while and do while, the difference is that in the while loop we are checking the condition before we execute the body of the loop, and then in the do while loop we are checking the condition after the first execution of the body of the loop. So when we talk about the for loop is actually consists of the multiple things. This is the header, and then we have the loop. Okay, we just try to remove that pointer here. Okay. So we have the header. In the header we have the initial actions, then we have the condition, then we have the post actions. So what has happened here? The initial actions, the first part, int I is equal to 0, that will be executed only one time when we are entering, when we are starting that particular specific loop, only one time. At the start of the execution of the for loop, we will execute that initial action only one time. So we will execute that particular specific part, int I is equal to 0, only one time. Then we check the condition. This is how it is, things are happening. So we come into that particular specific for loop, we execute the initial action, and it could be actions, multiple actions separated by comma, and I will show you in shortly. Initial action only one time. Then we check the condition. If the condition is true, we are going to execute the body, whatever that body is, one statement or two statements or five statements or 1,000 statements, doesn't matter. If it is only one statement, we don't need to put that brackets, but if there are multiple statements, more than one, then of course we need to put the bracket over there. And once we have finished our loop body, we are going and perform the post actions. Every time we are going to finish the body of the loop, we are going to perform the post actions. And again, here we have only given one action, but we can have multiple actions here separated by comma. So post actions, and after we have performed the post actions or action, we are going to check the condition again. So now this is the loop here. If we talk about a loop, the loop is here, that is checking that particular specific condition, executing the body if the condition is true, going back and performing the post actions, again checking the condition and performing the body, and then again post actions, checking the condition, body if it is true, and then we are, so this is our loop here. The initial actions are performed, but only once at the first time. After that, they are not being included in that loop or circle. And once that particular specific condition has become false, it will stop executing the body of the loop and come out of the loop itself. Make sense? So now if we talk about here, we have initialized the value byte I is equal to 1. And now if we look at that, we initialize that value, and then if we come down here, initial actions, I am just printing something on the screen. Okay? Console write line int 1, init1, int 2, or initial action, you can init 1, init 2, init 3. So what it will do, it will execute that particular specific, all the actions only one time. Print that particular specific thing on the screen, again print init 2 on the screen, again print init 3 on the screen, and once we have come out with that particular semicolon, initial action separated by comma, at the end of the initial actions or the list of the initial actions, we have a semicolon. This is a semicolon here. Once we have reached there, it means the initial actions has finished. Then it will check the condition. Condition is true or not? I is 1, 1 is less than or equal to 5. Yes, true. So it will execute the body. Body is only one statement. And what is that? Print number is 1. We are printing that number and 1. Number space 1. Print on the screen. That's it. Once we have finished the body of the loop, we will go and execute the post actions. We are going to execute the post actions. So what will happen? The first action is print something on the screen, post. It will print post on the screen. Then it say that I plus plus. So increase the value of I will become 2. Now we have executed all the post actions, and again we are going to go and check the condition. Follow flow. Now pre-actions or initial actions, they are not executed at all. They are not in the loop. Only one time they will be executed when you are coming into that particular for loop. So check the condition. If the condition is true, go and print the statement on the number 2, because now the value of I is 2. So number space 2 I, that's 2. Again come back, increase the value of I to 3. Check the condition. Condition is still true. Execute that particular specific statement. Again come back into the post actions, print that one, increase the value of I, check the condition. This initial actions only one time at the start. After that, they are nothing to do with the circular path or the repetition of the steps. Check the condition. Condition is true. Again print something. Number 4. Again come back. Print. Do the post actions after the loop body finished. Increase the value of I. Now check the condition. Condition is true or false? I is equal to 5. 5 is less than 5. True. Yes, no. So say louder so I can hear you. If I start, you will not be understand anything. So please try to communicate. When I ask a question, I am expecting something back from you guys. So condition is false. That's what I am expecting to hear from you guys. Condition is false, so it will finish. Loop is terminated. Done. You got it? Initial actions and the post actions. Any questions so far on the execution and the flow of that particular specific for loop? No? So once that particular condition becomes false, we will come out of that particular specific loop. Again, in that particular print star, we can do something like 4 int I is equal to 1, I is less than 10, I plus plus, print the number of stars on the screen. Int I is equal to 1, I is less than 10 and I plus plus. We are, it is a more compact way to write all those things. You know, in the while loop, you need to initialize that variable first. We are doing the same thing here, but it is the part of that particular specific structure itself. Okay? So that is more compact way to write the things. So initialize the value, and then this is the condition, this is the print statement, and this is the I plus plus. When you say I plus plus, is n plus equal to 1, because here I is actually, here we are using the I, but in the flow chart we are using n. So n or I, we just replace it. Any questions so far? Again, if you look at that one, in the sum of numbers, we can also do that. So we have init value I is equal to 1, I is less than equal to n plus, n sum plus equal to I. So, these are the two statements I put it over there, and then I put a semicolon over there. There is nothing to be done in the body. This is also possible. We are putting the header of that for loop and put a semicolon. There is nothing inside the body. Everything we are doing, we are using the pre actions or the initial actions, condition and the post action. You can say I plus plus here, and after that remove that semicolon and put sum plus equal to I. Yeah, that is the same thing. But remember one thing very carefully. You can't say I plus plus before sum plus equal to I. If you change that order, that will give you a wrong answer. The reason is that you are increasing the value of I before you are adding in this sum. You know, so we need to make sure that we are putting in the right order. And we are just putting the semicolon over there at the end, because there is nothing in the body, so we can put a semicolon. That for structure of the for is finished. And there are different way to do the thing, you know. Even you can say for semicolon 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 at the end. For parenthesis 2 semicolon parenthesis close and then semicolon. That will become infinite loop. Infinite. The reason is that you don't have any initial action. Okay, fine. You don't have any condition as well. Do we have a marker here? No. Okay. I will just try to write it down here using my pen, if I can write it properly. Pen. So we say for, and and then here we put a semicolon and again put a semicolon, and then if we write something like this, it is an infinite loop. There is nothing inside the initial action. Okay, fine, it could be possible. If you don't have any initial action, you put a semicolon, done. No initial actions. And then after that we have a condition. Again, you don't have a condition, you put a semicolon. When you don't have any condition, it means it is always true. When it is always true, that loop will never finish. Infinite. And after that you have the post actions, and if you close the bracket without giving any post actions, it means there is no post action. We can write that particular specific for loop in a multiple ways. Okay. So let me show you how we can do that. Okay. Okay, so let me stop that thing over here and try to delete everything from here, and I will show you how we can write for semicolon semicolon and semicolon. This will become infinite loop. Is the spellings are correct? Infinite. It should be combined together. Infinite loop. We can also have, I say int I is equal to 0 for, now I don't want to initialize because I have already given that particular specific initial value I is equal to 0. Int I is equal to 0. And then we say I is less than 5, and then I don't have anything in the, I also put sum is equal to 0, and then you say sum plus equal to I, and put a semicolon over there, I plus equal to 1 and put a semicolon. I mean, we have that particular specific thing in the post action, or you can write it here, doesn't matter, because you done that thing, after that you are doing this thing, fine. Same loop, multiple way to write. Okay. You can also have that particular specific thing here. Okay, we will do it later on. So I mean, same thing we can do in a multiple ways. Any questions about that? No? So in infinite loop, while true, we are putting true as a condition. So definitely that is not going to change. This is a constant value, always true, infinite loop. If we try to run that thing, it will never finish, theoretically. But nowadays, these these systems are more intelligent, becoming. They are trying to break that thing later on. Eventually, it will stop, but theoretically, it should be an infinite loop. It will never finish. Okay. So again, using the do while, this is a while infinite loop. This is a do while infinite loop. For the condition, we are giving the true value. For the what you can say that for the for loop, again I am doing the post actions, but it is again there is no condition given. When there is no condition given for the for loop, true, or you can put true as well. For the condition, you put true, just like we did for the true while and the do while. Condition is true always, so infinite loops. There are different ways to write it. Clear? Now the problem is, if you want to do something like this, you are developing a program like calculator. You don't want it to finish. You start the program, it should continue, ask the user again and again and again and again. You don't know how many times the user is going to perform the addition actions or the multiplication or division or subtraction or something like that. You don't want to stop that program. Then we should have a way out in that situation. Under a specific condition, we stop that loop. Okay? So we have a break statement. When you put a brake in your car, it stops. So similarly, we have a break statement, just like we have a break statement in which statement we have studied the break? Huh? I can't hear. Switch. So switch is the statement where we stop. Whenever you put a brake, it will come out of that particular specific structure. That is a switch structure. So here, when we ever say break, it will come out of that particular specific loop. In the body of the loop, whenever you are executing the break statement, it will stop that particular specific loop. We are saying that while true, infinite loop, I plus plus, and we are checking if I is equal to 100, whenever the value of I will become 100, it will stop that loop and print the value of the I on the screen. You got it? Loop, break, break. Finish the loop. Again, in the do while, same thing. We are checking while true, it's an infinite loop. In the body of the loop, we are checking that if the value of I become 100, break it. Break means it will immediately stop that specific loop. Adding users numbers. Remember that we are asking the user to give me some number, and then we are adding them together. So and then we check while that number is not equal to 0, we are going to repeat that things. Here we say no, it's an infinite loop, and then we say if n is equal to 0, the value that is given by the user, if it is 0, we are going to break it. We call it a sentinel value. 0 is a sentinel value where the loop is going to finish. And again, we give those values, it will give me the same answers. Doesn't matter. Do the same thing, except that we are using the infinite loop, and inside the loop we are checking that if that value is become specific, equal to some specific value, break that particular specific loop. Print even numbers. We have a break, we also have a continue. So what happened in the continue? So, we are saying that I is less than equal to 20. Then we say I plus plus, we start with 0, I plus plus, I will become 1, yes or no? I is equal to 0, I is less than equal to 20, yes, condition is true. I plus plus, increase the value of I, it will become 1. 1 remainder 2 is not equal to 0, yes or no? Yes or no? No. It means I remainder is not equal to 0, that is true. 1 remainder 2, his answer is 1. So, that is not equal to 0, yes, it is true. So, what will happen? That continue statement will be executed, and once we continue, it will go back to check the condition again. It means it will consider that we have executed the body of the loop, and then we are going to check the condition again. It will not execute that particular specific print statement, even number is plus I, not going to be executed when it is I is 1, 3, 5, 7. Next time again I is less than equal to 20, I is 1. 1 is less than equal to 20, yes. Come back here in the I plus plus, it will increase the value of I, that will become 2. 2 remainder 2 is equal to 0. Yes, it is true. But we are what we are saying? We say it is not equal to 0. It means that condition will become false. 2 remainder 2 is not equal to 0, that will become false. It means this continue statement is not going to be executed, and it will print the even number 2 on the screen. Make sense or not? Next time again go back, 2 is less than equal to 20, yes, it is true. I plus plus, make it 3. 3 remainder 2 is not equal to 0, true. Continue will be executed, and it will not print that number on the screen. So, we are only printing even numbers on the screen. So, continue will stop the execution of the body and go back just like that it has finished the body and go back and check the condition. Make sense or no? The continue statement, break and continue. Break mean finish the loop. Continue mean if there is some statements which are still to be executed in the body, do not execute those statements, go back to the header of this loop and check the condition again in that particular specific case. Is it clear that what continue is doing? Again in the for loop, for int I is equal to 0, I is less than equal to 20, there is no post actions. Post actions are being done here, and then we can continue. Continue mean that we are not doing it here. We can put that I plus plus here as well. If continue, actually it will go back to the post actions and increase the value and then check the condition. Let's try it, before you can take my words, and I can also check that am I right or not. So, we come down here, I delete that particular specific again. We are saying that for int I is equal to 0, I is less than equal to 20, I plus plus, and then we are checking that if I remainder, where is the remainder? I remainder 2 is not equal to 0, we say continue. In the else part we say console dot write line even number I. Okay. So, because we are starting with the 0, it will print 0 as well. So, let me run that program and then see that how the things are going. In the continue, after the continue, actually it will go back and perform the post action or actions if they are multiple. So look at that, 0, 2, 4, 6, 8, 10, 12, 14 up to 20. It has printed only the even numbers. So whenever we are talking about the what you can say that continue in the for loop, actually it will go to the post actions. If there are some post actions, it will perform those post actions and then check the condition. The same thing, the same after the body, whatever is happening, exactly the same. So we can put that I plus plus here in the post action. Clear? Any questions? Sentinel value, the value which help us to break the loop. Just like we check if the user is giving the 0 value, then we are putting a break. So a value to terminate the loop can check if for the terminal value after user input, if the sentinel value then break the loop. If the sentinel value is there, we can check this thing in the if condition, and if that sentinel value happens, we put a break statement and it will stop that loop. So asking the user to continue, if the user want to continue, yes or no. So again, based on that particular specific statement, we are going to execute the loop. Enter y to continue and n to the quit. So when you say y, it will continue, otherwise it will stop. So y is a sentinel value. In the other case, when we are talking about the 0, 0 is a sentinel value. So sentinel value can be anything which help you to break the loop. It can be a number, it can be a character, it can be a string, yes or no, it can be a true or false, anything. So 0 is a sentinel value. If the n is double equal to 0, break it, sentinel value. Now which loop? We have 3 loops, while, do while. I give you the difference between the while and do while. So we can't check the values. That's a one scenario where we need to have a do while loop, that when we are asking the user to give the value and then we are validating, it means that we are validating after the input. So we first time we do it and then we check. So for loop concise, compact and enables to write the code with less errors. But most of the time, when we exactly know we are going to run that particular specific loop 100 times, 200 times, 300 times, then we normally try to use the for loop. Plus plus starting the value and ending the value condition, it will help us to exactly we know how many times that particular loop is going to be executed. For loop. But if we have the while and do while loops are used when we don't exactly know. We based on the condition we see that it is going to be executed or not, rather than how many times that loop is going to be. Whenever we know that how many times, it is always try to use the for loop, and if that is not the case, we don't know how many times it is going to be executed. Of course, we can do the same thing using the while, do while and the for, doesn't matter. We can do the same thing. The whatever we can implement with the for loop, we can implement with the while loop. Whatever we can implement with the while loop, we can do with the for loop as well, do while loop as well, doesn't matter. Now it is totally preference that I like for loop, I do the for loop, no problem. I am very comfortable writing in the while loop, okay, write the while loop. It will do the same thing, doesn't matter. In the for and the while, condition is tested before the execution of the body. This is called pre-test. We are testing, we are checking the condition and then execute the body. That is the one main thing for the for and the while loop. Check the condition, then execute the body. And on the other hand, do while is a post test. Execute the body and check the condition after it. Okay. So these are the two differences. So whenever we are in a pre-test situation, we can use either while or for. If we are using the, we are in a situation where we need to check the condition after, then we say post test. So, it is better that use the do while. Okay. Math class. Any questions so far about the loops before we can jump into that math class? Don't worry about that. This is a math class which is a predefined class, just like string class which is already there. We can just use them. We have those methods, we will execute them. But do you have any question related to the loops? While loop, do while loop, for loop? Any questions? No? Okay. So, we have a math class which if you click on that particular specific reference, it will take you the documentation. In that particular specific class, they have two constants which has been defined, which are the double pi and e. Okay. Pi, I think you already know that circular, related to that circle, geometry. E is also a constant, logarithmic, natural logarithm. We have logarithm of base 10, logarithm of base e, that is called natural logarithm. That base e is actually this constant value. I am not going to explain you that what is e, how it is being executed, created and so on. It is a constant value which has been defined in that math class. And in the math class, we also have some methods. Remember that in the string class, we have the split method, we have the length property, we have the substring methods. So, these are the methods which has been already defined in that class, and we can use them for our purposes. What we need to do, what we need to understand is what we need to provide as an input to those methods and what they will return us. That is the only thing we need to know. How they have been implemented, how they have been coded, we do not need to worry about that. So, here we have methods ceiling, floor and round. These are the more like rounding the numbers, 3.56 rounded to 1 decimal point, 3.6. 3.56 will become 3.5 because the number that you are dropping is greater than or equal to 5, the previous number will be increased and so on. So, we have ceiling, floor methods, and then we have power 2 raised to power 4, 5 raised to power 10. If we want to compute something like that, we have a POW method. SQRT, that is a square root. We have min, max and absolute, sine, cos or tan. Remember right angle triangles, geometry. In the right angle triangles, we have the sine and cosine and the tangent of those angles. Okay. Yes, we can do that. All those things we need to provide them. So, here we are saying that ceiling, we are applying ceil on the x. So, we have 3.4. Number one thing, ceiling method will take a double value as an input. So, we have double value 2.4 and it will return me as an integer value. It will return me a complete number. So, actually this ceil 2.4, ceiling mean it will go up, 2.1 it will go up 3, 2.00001 up 3 because it is more than 2, 2.0000000000001, okay. Still it is more than 2, it will go up. The nearest complete number which is greater than that, ceiling up. Floor, again it takes the double value and it will give you the number which is complete number which is less than or equal to that particular specific input value. 2.999999. It is very near to 3, but when you say floor, it will become 2. 4.8 it will become 4. 4.8 actually it is more near to 5. If we round it, it will become 5, but here we apply the floor, it will come down. And then we have round method 4, we are applying on the z 3.567. If you say only z, it will round to a complete number like here 3.5. If actually it will round it 7, it will become 7, the 6 will become 7, 6 is 7, it will become 6 and 3.6 it will become 4. If you give only the value, it will give you a complete number as an answer. But if you say something like this z and 2, it means after the decimal point we want 2 digits. So, it will remove the third digit and make it 3.57, and if we say 1, what it will do? It will first will remove the 7, then it will remove the 6, and that will become 3.6 Z1. So, round, floor and ceiling. Floor mean the number, complete number which is less than or equal to the input value. Ceiling mean that the number which is greater than or equal to the that value, the nearest complete number, and round mean that it is going to be rounded based on if you give only the value, it will round to the complete number, and if we give the second argument or second parameter, that is z or 1 or 2 or 3, and based on the decimal numbers, how many decimal numbers we want after the decimal point. Clear? Again we have these math class, and then we have a power method. So, power is x raised to power 3. So, it will compute x raised to power 3. Square root 36, when you say square root, it will compute the square root and give the answer 6. Then we have absolute method. Absolute method mean that if we have the negative value, it will give me the absolute value of that number. Minus 2 is actually 2, plus 2 is 2, 0 is 0, but negative values will become positive in that particular specific scenario. Minimum method mean we provide two numbers and ask them to find out the minimum between these two numbers. Max method, give two numbers and ask the method to give me the maximum number or the largest number between these two. Min, max and absolute. Nested loops, we can, just like we have if statement, inside the if statement we can have the loops within the loops. So, if you want to print something like this, we try to use another statement. Remember before we say that enumerable print this much stars on that line. So, here we are just say star, we are printing those stars ourselves. We are saying that if I is equal to 1, starting value, I is less than or equal to 10, it means we are going to print 10 lines, and then I plus plus. And for each line, what we want? We say j is equal to 1, j is less than or equal to I, and print star. So, what will happen? J is 1 the first time. Now, this is very what you can say that it is very important to understand that how the things are moving. We have a line, so I is equal to 1, and then we have j is equal to 1. We come down here at that particular specific line, I is equal to 1, I is less than or equal to 10, yes, it is true. Come down here. Now, we have again another loop, j is equal to 1, j is less than or equal to I, 1 is less than or equal to 1, yes, it is true. We print 1 star, we print 1 star on it, fine. And then we are, once this is the body of the inner loop, that is the inner loop inside. Okay. So, once this is finished, it will go back, increase the value of j. So, this value will become 2. Yes. Once it will become 2, what is the condition? 2 is less than or equal to 1. So, that loop has, the inner loop has finished. Now, we are saying go to the new line. So, we have printed that particular specific line, and then we go to the new line, here, new line. Then we go back, increase the value of I plus plus. So, increase the value of 2. Make sense so far? Check the condition. 2 is less than or equal to 10? Yes, it is true. Again come back in that inner loop. J is equal to 1. So, again that will become 1. 1 is less than equal to 2? Yes, it is true. Print 1 star. So it will print only this first star. Go back and increase the value of j become 2. This j. Now j become 2. 2 is less than equal to 2? Yes, it is true. It will print the second star. Again, increase the value of j by 3. Now 3 is less than equal to 2? No. It will go to the new line. And then increase the value of I. So increase the value of I, that will become 3. 3 is less than equal to 10? Yes, it is true. And come back and make the j is equal to 1. When we are coming again from the first, so that initial action has always been proved because this loop has finished. Now in the second time outer loop, with this we are restarting that loop, restarting that loop, restarting that loop. So j is equal to 1. Again print the 1 star, increase the value of j to 2. Again check the condition, condition is true, print the second star, increase the value of j to 3. 3 is less than equal to 3. Yes, again true, print the third star, increase the value of j is equal to 4. Now the condition has become false, go to the new line. So in this way we can continue, and actually it will print all those 10 lines for me. In the first time it will only print 1 star, second time it will print 2 star, 3 star, 4 star, 5 star and so on. Make sense or no? Clear? Good. So we can print something like this as well. Multiplication table, 1 multiplied by 1, 1 multiplied by 2, 1 multiplied by 3. If we talk about 3 multiplied by 1, 3 multiplied by 2, 3 multiplied by 3, 9, 3 multiplied by 4, 12 and so on. This is a table, and we can't print it using only one loop. So we have to have a nested loops. So this is our, what you can say, that for loop I is equal to 1 to 9 I plus plus. Again j is equal to 1, j is less than equal to 9 I plus plus. So for inner loop we are printing that one line, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the 1, and then for 2, for 3, for 5, 5. So actually this particular inner loop is actually printing those values, multiplications. I multiplied by j, I multiplied by j, I multiplied by j. For 1, for 2, for 3, for 5, for 6, for 7, for 8, for 9, for 10. Not 10, for 9, up to 9. Is it clear what's happening? So that is the output of this particular specific program which I have just shown you. And any question before we can jump to the next problem, which I was discussing in the beginning of our lecture. I mean, I see these lectures a lot of times, so I was thinking that I have already delivered that. But anyway. So again, as I told you that we have 54, 55 students in this class, and if I need to get the marks for everyone and maybe compute the average, find out the maximum number in the in that specific assessment or the minimum number of the assessment, finding the average, what are the average marks for whole of the 50 students? Yes, it is possible, but the point is, do I need to have that 50 variables or 55 variables to save all those records and then adding them together and finding the answers? For average sum of the marks, finding the minimum, maximum, we need to, I mean, we know how to find out the average. If we have 50 students, we add this the marks of all the 50 students and divide by 50, we get the average. Similarly, we want to find out the maximum number among those 50 students who got the highest marks, who got the lowest marks. We can find out all those things. But the point is that if we need to declare 50 variables, int student 1, student 2, student 3, student 4, student 5, student 6, student 7, create 50 plus variables, calculating sum and finding the average. not a good idea. So, next time we will try to answer this particular specific question, that how we can solve on these kind of situations when we have a list of numbers or list of names and so on. For example, we have first name and last name, and I want to search some specific student if it exists in my class or not based on the last name. I mean, wherever we have multiple values of the same type, we don't need to have the multiple variables of the same type. We can have one variable and then try to maneuver that how things are moving. Okay, so that is the end of our lecture today. Any questions so far?